operations example. And the example is a radio access network, a transport network, and a extended an EPC network. The EPC consists of an MME and a serving gateway. There's an EMS that controls the E-Node-Bs in the RAN network. There's an EMS that controls the routers and switches in the transport network. The EMS for the RAN is provided here by ZTE. The EMS for the transport network is provided by Juniper. These are operating with existing standards. They are approximately 20 to 30% open standards and approximately 70 to 80% proprietary interface. Orchestral Networks is providing an adaptation and enhancement layer. This layer communicates with the northbound interface of the EMSs in their native existing interface. The adaptation layer provides an open API. The open API is based on the Umbrella Information Model, which is developed in response to NG Core. Most of the work was done by 3GPP, SA5, and TMF. There were several other organizations that contributed. It is an information model only. It is not a complete model. The first rev portion of the model has been published by 3GPP. TMF plans to publish another piece of the model at the end of this year. Orchestral Networks has created an open API based on this model, based on 3GPP standards, and provides that interface to Comarch, which is providing configuration management, and to HP, which is providing inventory management. The use case for this project comes from the champions, Deutsche Telekom, Orange, France Telecom, Telefonica, and Telecom Italia. And it's based on a small network of two E-Node-Bs in the same neighborhood with a coverage gap between them, which requires the installation of a third E-Node-B. When the use case starts, the two E-Node-B network is operating, the transport network supporting it is operating, and they are connected to the MME and serving gateway and the UPC. Pablo?
Yeah.
From HP, we'll start by describing the existing network as it appears in the inventory management system.
Exactly. So here we have HP TrueView inventory that's acting as the network inventory in this Catalyst project. And what we have here is a view of the current network related to the Catalyst, where we can see the two actual E-Node-Bs connected to the network, connected to the VLAN and to the switches that make the connectivity through the backhaul against the software gateway and the MME.
We'll now explain how the configuration management system interacts with the total demo.
Before we get into configuration management, design is like we can see that file has been generated. Now we are going to use to demonstrate the CM bulk protocol.
What a session is going to allow them to do is create uploads and downloads. So in this instance, they're going to create a download both to the ZTE EMS, then later to the Juniper. We'll convert that from the 3GPP format into the vendor-specific formats, and then when they're activated, we'll send those to the devices, do verification, and send notifications back to both inventory and configuration management, anyone who's subscribed.
Thank you, Greg. So in a previous demo, Orchestral Networks showed its graphical user interface and its enhancement functions. In this demo, Orchestral Networks is just showing the log of the actual operation of the adaptation and enhancement layer. The ZTE EMS uses the 3GPP bulk file transfer protocol. The Juniper EMS uses a REST interface. So instead of a bulk file interface, it receives a URL, a body, and responds across the REST interface back to the orchestral adaptation and enhancement layer. When the orchestral layer receives confirmation that the configuration changes have been made and are actually functioning, it sends back a message to Comarch and to HP saying that the process has been completed.
As you can see, Orchestra Networks is receiving the CM Bark.
Right, we've sent out notifications now that the download's complete and ready to activate.
So now after receiving notification from Orchestra Network that the download has been completed, now I'm pushing the activate command.
That's because we're using real devices here, or real EMSs here. The eNote Bs and the Juniper network devices are being simulated, but these EMSs are real software. So what we're doing now is first we're kind of mirroring the process that we've made available to Comarch, to the EMS. We've done the download.
For radio configuration.
So now what we'll do, we will come back to Truby inventory and we'll update the network view.
Thank you, George. So in conclusion, we've shown how with a single system, end-to-end, we can operate a radio access network, a transport network, and the EPC using multiple vendors and multiple interfaces. Thank you.